In part two of chapter 8, we're going to talk about soils and mining, both of which topics we're going to do labs with. Soil. So we've talked about plate tectonics and we talked about the rock cycle. And the third part of the geologic cycle is how soil forms. And soil is important because it is a mixture of geological and biological components. So it connects biology to geology. Several reasons why soil is important. It is the medium for which plants grow. It serves as a filter for water as it moves from the atmosphere into groundwater, rivers, and streams. It provides habitat for many organisms. And then it also filters pollutants that, as they come from the atmosphere down, the soil will start to filter them out. So there you see the uh, the benefits and importance of soil. It takes hundreds to thousands of years for soil to form. We saw, and I forgot which chapter, about primary and secondary succession. When an ecosystem has not existed in a certain place, say when a glacier has retreated and exposes just plain rock, it takes a very long time for soil to start to form because first you need organic matter and mixing with eroded rock in order to start forming that soil. So you have to have soil in order to have the future plant life. Okay, so soil is the result of physical and chemical weathering of rocks and the gradual accumulation of detritus from the biosphere. There are several things that will determine what kind of soil you're going to have and the formation of it. First is the parent material. The parent material is the rock, like the bedrock, and that is what the soil is made from. And so you could have quartz, sand, which could be a parent material, and if you have a sandy soil, that's generally nutrient poor. Or you could have a lot of limestone in it, and when you have a lot of limestone, you have a lot of calcium, and that could be very productive for soils. Climate obviously is going to influence what type of soil. Um, if you're in a high latitude location where it's freezing, then you're not going to have a whole lot of soil because you don't get that biological detritus very easily because they decompose very slowly there. So, and if it's frozen, it's not going to form very well. On the other hand, if you're in the rainforest, there's tons of rain. It actually ends up being very acidic, but there's still a lot of soil formation going on there. So climate's very important. Topography is basically the landscape. Um, how that surface is arranged. So soils that are on steep slopes are obviously going to be constantly subjected to erosion due to gravity, and then sometimes that's where you get the landslides or the mudslides, and so you can get a lot of erosion of soil. Um, or if you have some that are on the bottom of steep slopes, then you have a lot of material accumulating and you could have very deep soil. Organisms, well, obviously, if organisms are living in the soil or they burrow in the soil, like earthworms, those can um, influence positively or negatively the soil. And then time. Um, the longer the soil gets to stand there and develop, it's going to be maybe more fertile. And certainly deeper. So it would be more fertile the longer it has the time to accumulate the mineral and biological components. So the different layers of soil. First, you start with the parent material, and you can see in this diagram it's really like primary succession or even secondary succession if the ecosystem was wiped out. You start with just plain bedrock and you have very immature soil. So it's going to take a while for the eroded rock material to blend with the dead biological organisms. Then over time, as you have those mosses and fungi, they start to die and that detritus mixes in with the eroded rock, you start to have soil start to accumulate. So after hundreds to thousands of years, then you have much more soil. So you have several layers of soil, and these are ones you do need to know the different horizons, know the order of them and the basic characteristic of each, but it hasn't been known to show up a whole lot on the AP exam, but it's a good idea to know them. So notice that you have the O horizon on top, then A, then B, then C. So let's go through those. So the O horizon is the organic layer, and this has all the leaves and sticks and animal bodies, the dead bodies that have fallen on top. So the O is for organic, and that's where you get a lot of the humus. When you're looking at some soils and you see the really dark, nutrient rich material, that's the O layer, the organics. Um, Beneath that, you have the A horizon, and that's called the topsoil. So that's when you have a lot of the rock material mixed in with the organics or the biological material. The B horizon is the subsoil, and that has mostly mineral material or rocks and little organic matter. And then you have the C horizon, which is going to be the least weathered horizon because it's so deep. It can't really be broken down unless the tree roots are coming down to physically break it up. And it's similar to the parent bedrock because the bedrock is the very bottom where it's just plain rock, the basement rock, and that's where the soil started was with the sea horizon, where you first had the minerals and the rocks being eroded down and mixing with the dead mosses. When you're looking at texture, and we will be doing that in our lab, you're looking to see what percentage of sand, silt, and clay you have. And you see the picture on the right where it gives you the relative particle sizes of sand, silt, and clay. So when you go from largest to smallest, sand is the biggest, silt is the middle, and clay is the smallest. So notice the clay minerals are very, very tiny. These you'll tend to see in the ocean floors way out in the abyssal plain because they're so tiny they don't sink very easily. They're easily moved and so it takes a long time for those to settle. So when you're looking at texture as you will be doing in your lab, you figure out what percentage of clay you have versus the percentage of silt versus the percentage of sand, and you follow those along the line. So if I had 40% sand, I find the 40% here. I have 40% silt, I find it up here, and then 20% clay. So I find out where they intersect. And in this example, it intersects at loam. Loam is actually the most preferred type of soil for growing things or for agriculture because it is a nice mixture of the three soil types. You don't want to have one that has too many particles of clay because of the porosity. So if you look here, when you put water and you let it percolate down through sand, it goes very quickly. You see it only takes an hour. When it's silt, it takes 100 days for that water to flow all the way down through the silt. It would take 100 years for the water to percolate all the way down to the clay. And that's because those particles are so tiny that they stick together and they form what's an aquiclude. An aquifer allows water to flow through it like limestone so that we have our groundwater. An aquiclude is basically a layer of clay that doesn't allow water to go through um, because there's not a whole lot of space in between the grains for the water to flow through. So know that loam is the best agricultural soil because it has a mixture of all three. So you don't want your soil to have too much clay, but you do want it to have some clay so that it does hold on to water and nutrients, which is why you don't really want sandy soil, um, because as you see in this diagram, the water would drain through too quickly, and so it remains nutrient poor. Chemical properties of soil. We will be looking at the nutrients in soil, and we'll be testing to see how much potassium and nitrogen is in the soil. Um, we won't be really looking at the cation exchange capacity, which just is the ability of a soil to absorb and release cations. So clay particles have a negative charge. Cations are the positive ones. So clay particles attach to the cations, um, and those can be used by as nutrients by plants. So basically, if you have too much too much clay, then which is more than 20%, then it holds on to the water. So if you were, say, irrigating and there's too much clay, then the water will kind of be stuck there. And then those crops become what they call waterlogged, which means the water just kind of sits there and drowns the plants. And that's not good either. Um, so you want to have a good cation exchange capacity. Another chemical property of soil are the acids and bases. So bases would be calcium, magnesium, potassium, and sodium, and they tend to neutralize the acids, which would be aluminum and hydrogen, and those will promote plant growth. So you want a nice amount of your bases. Acids, as it might sound like, tend to be detrimental to plant nutrition. So bases help plants grow, acids seem to not. So you definitely want to have um, a good base saturation, which is comparing the bases to acids. So if you have a high cation exchange capacity, which retains the nutrients, and then you have a high base saturation, which means that it has a lot of good nutrients for the plants, then you're going to have a good productive soil. So in agriculture, you want a high base saturation, which has the nutrients, and the cation exchange capacity, which will allow it to hold on to those nutrients. Many organisms are found in soil, so we need those. That's about it. Before I go on to mining, it's just important to know that when it comes to soil, humans have done a lot of degradation to soil over the past, well, many years. Um, and a lot of it has become from agriculture and clearing areas for development. And whenever you have agriculture and you are, constantly dredging the soil and planting on it, remove the crops, harvesting the crops, and then you're doing it all over again, you're taking away the nutrients of the soil, and then those kinds of people will move on to another section of the forest or the area. And so, tearing down the trees and then developing them does lead to degradation of the soil. It the soil can't hold on to the nutrients if there's no trees around there, so the soil becomes less um, nutrient rich and it doesn't become productive. And then people will tend to wonder, well, why is nothing growing around here? Well, for one, you keep reusing the same soil and you're not allowing it to regain its nutrients. And then you're tearing down the trees so the roots can't help anchor that soil and it leads very easily to erosion. All right, so now we get to mining. Ores are accumulations of minerals from which economically valuable materials can be extracted. So typically ores are metals, and those would be like copper, nickel, aluminum, iron. Those would be metals. And they will tend to vary in their concentration, and they normally are attached to another mineral. So like with pyrite, for example, is iron sulfide. Some, though, you do, like with gold or silver, you will find in their natural form. So some ores are found from the deposition of igneous rock, some are found in veins, and then others are called non-metallic mineral resources, and those would be like clay or salt. When you want to mine for salt, limestone, we use that for building. So they don't have to be metals. A reserve is the known quantity of a resource that can be economically recovered. And since private companies tend to hold the rights to many, resources, they don't always say exactly how much is there. And so they'll many times they can tend to lie about how much is there, saying there's really not that much and there could be more. So you can take a look at that chart and see how much of the reserves are remaining. So there's two types of mines, and what mining is extracting the ore from the earth. And so there's two kinds. There's surface mining and subsurface mining. And each kind of mining is going to have pros and cons, just like what we talked about with trash. No matter what we do with the trash that we have, it's still going to impact the earth in some way. So surface mining is removing minerals or ores that are close to the earth's surface. Strip mining is the first kind, and it's taking obviously strips of soil off the surface to uncover the deposits of minerals. That's how we can get coal or large amounts of sand. And when you take those parts off and you get your ore or your mineral, whatever you do want, and you have leftovers of the stuff, the rock and other minerals that you don't want, those are called spoilings. Spoils or tailings. And the spoils is what's kind of left over. And when we were watching The Last Mountain, it's the spoils that they have to put back into the mountain when they were finished. And then you don't really have that's their way of reclaiming or reclamation, is trying to make it look like it was before they did any mining. And obviously, it's not going to look like it did before. And we'll experiment with this in a mining lab that we do in class. Open pit mining is basically, well, creating a large pit. Copper mines are generally um, open pit minings, and so that's just, you know, getting it from the big hole. In mountaintop removal, that's doing what they did in the last mountain, where they set explosives up and basically one little by little take off the top of the mountain, recover the coal or whatever mineral, and then reclaim and put all the spoils back on top of the mountain. And that's, from the lower levels of the mountain is where the spoils were getting dumped and going into the water supply and poisoning the water. In placer mining, that is looking for metals in or stones like diamonds in river sediments. So when they're panning for gold, that's what they're doing, is placer mining. If you've ever seen the movie Blood Diamond with Leonardo DiCaprio, that's what the African workers were doing, were panning for diamonds in the water. When you go below the surface, which is about 100 meters down, that's when you do subsurface mining. So first you start with a horizontal dig, and then you'll start to go vertically down. And so a lot of subsurface mining they've done with coal as well. And you can see the effects of both types of surface and subsurface mining. So do pay attention to both kinds. I got interrupted, so I don't know exactly where I was. But do make sure that you read pages 228 and 229 when you're talking about safety and the environment. Um, but basically, all types of mining are going to require construction so they could carry in and out whatever it is that they're mining, which is going to um, damage habitats, is going to damage water, especially if you have accidents. We talked about mountaintop removal, and you saw how that was harming communities in Virginia. It also makes water have a very high, or excuse me, low pH, which makes it very acidic and poisonous. Subsurface mining is probably the most dangerous because as you're down there and you have gas buildup, and you just have the mining particles down there, it makes people very sick. They get black lung disease, respiratory disease. Um, and then, of course, it could catch on fire and they have explosions. We've had many explosions in coal mines, and um, hundreds of people have died. The mining is not going anywhere because of the increase in human population. So it's important that we find other ways of trying to extract things without damaging the environment and or people. That is the end of part two.